Okay, so post 6, question 5, part C, and then we'll do D. Go to the molecules mode by selecting the icon at the bottom. Notice that there are 3 real reactions: the synthesis of water, the synthesis of ammonia, and the combustion of methane. Select each of the reactions. Observe the reactants taking part in the reactions. Suppose you are carrying out each of these reactions starting with 5 moles of each reactant. Observe that some reactants are in excess, whereas some reactants limit the amount of products formed. Classify each of the reactants as limiting reactant or an excess reactant for reactions starting with 5 moles of each. Okay, so what you have here is, I guess I'm just going to have to work off this here. Okay, so you have these different deals, right? You have these different reactions, which you were supposed to look at in that previous part, right? Okay, so let me get up to the reactants. Oh shit, it's one of those videos. Get the video to play for me while I'm on here. Okay, so you got your molecules, you're doing that one. You enter in here, and I would just go ahead and put 5 of each, right? Okay. And see how before the reaction, you're mixing those 5 together of each, right? And after the reaction, you have one of the reactants is left over. You didn't use it all. And so we call that a what? If you had an ingredient in your, let's say you're making like cookies, and you use up all your sugar, and you have flour left, you would call that flour excess, right? Yeah. So the oxygen in this case is your excess reagent, isn't it? Okay. That's the one that you have plenty of. Your hydrogen is the one you're running out of, okay? And so that would be your limiting reagent. And so you'd come down, you'd get to your problem, and your H2 in the formation of water is your limiting reagent, isn't it? Your O2 in the formation of water would be your excess reagent. Okay, so the next one, you go over again, you're making ammonia now, right? Again, you're told to do 5 in each, right? There we go. And so, in this case, you're left with lots of nitrogens left over, right? You got it. And you're left with very few hydrogens left over, aren't you? Okay. And so hydrogen would then be your limiting, right? H2 formation ammonia, limiting H2 formation, or N2 formation ammonia, excess. Okay, then you do your next one. At this point, hopefully you're just going, well, duh. Again, because you have 5 for all these, right? Because it's 5 moles, 5 moles. You don't really need to put these in. You could actually just look up here. Whatever number has a larger number here is your limiting, right? Because it's going to get used up faster. Whatever the number is smaller up here is going to be, yeah, because it's the slowest one used up. And that's that, yeah. So, anyways, it's pretty straightforward once you actually do it, right? Yeah. By the way, this is a concept problem. It's meant to explore limiting reactants and make you intuitively understand, rather than just, being told. All right. And then you said part D? Okay. So find the number of moles of water that can be formed if you have 158 moles of hydrogen gas and 74 moles of oxygen gas. So again, your reactions are all in these things, right? That'll make your life easier. Why not? So make water. Okay. And notice, by the way, this problem is actually kind of ridiculously easy. You don't even have to do the math. so you could actually just like put in numbers here, couldn't you? But I would do the math personally. I find that to be faster, easier, and it really proves that you actually understand it. So the easiest way always to get your limiting reactant is always to see how many moles you would end up of your product. So the limiting reactant is the one that makes the least number of moles of product, right? Because it's going to be the one that runs out first. So, yep, you take your 158 moles of hydrogen gas, and then you would take your ratio here, wouldn't you? So, times 2, divide by 2. So 158 is your answer. It's times 2 divided by 2. They cancel. Yeah. Anyway, so your hydrogen would give you 158 moles of this H2O, right? Okay. Now we look at the 74 moles of the oxygen gas. And we look there, we have 74 moles of the oxygen, right? So 1 mole of oxygen gas would give you 2 moles of the water. 74 would give you, times 2, so 100 and... You got it. 2 times 7, 14, right? 148. And so your oxygen would give you 148 moles of this H2O. That's less than 158, isn't it? And so that would give you the least number. That would give you your number of moles of water that you could get. Mm-hmm. In the case of these numbers here. Yeah. Okay. Okay, yeah. Don't forget, folks, whenever you do these, make sure you get your own numbers, okay? Okay. Okay. Yeah, you actually did a problem harder than this with me like Tuesday, didn't you? Or not Tuesday, but Monday. Yeah. With actual like grams and everything. Not with the demonstration.